Take just a minute to read this problem. Notice you've been given an objective function and a series of constraints. Oftentimes you're asked to figure these out. This time they've been given to you. The first two inequalities are trivial and are just the x and y axis. The next two are a little harder to determine. You may want to put them in y equals mx plus b form, but I would encourage you instead to find the intercepts. When you let y equal to 0, then x must be 20, because 2 times 10 is 20 plus 0. That leads you to this vertice. Similarly, when you let x equal 0, y must be 20, leading you to that vertice. I've taken the liberty to plot them. Here we have 0, 20. Here we have 10, 0. The same work with the other equation results in vertices of 0, 8 and 12, 0 by plugging in x is 0, solving for y, and vice versa. Those two vertices are plotted here, and those two vertices are plotted here and here. This one is over 12, up nothing. The last one we need to figure out is where the two graphs meet. That's done by solving these two equations equal to each other. I would subtract or multiply the bottom equation by a -1 and then add them together. When you do, you get the following. After elimination, y equals 2. We'll plug this in for y, and when you do, x can be solved for 9. That leads to this vertice here. The area we want is inside everything, so it has to be below the black line and inside the red line. So we're looking at 0, 0, 0, 8, 9, 2, and 10, 0. These vertices can be ignored because they're not in the feasible region. We'll take all of these coordinates and plug them into the objective function. Keep in mind you were asked to find a maximum and a minimum. 0 and 0 produces 0, that's the minimum. 10 and 0 produces 40, that's the maximum. To finish up, those values are recorded here.